trying out things. I am also I am also developing a starter. So this Aztec starter is basically very basics. Yet yeah, very effective as well. But there is no web integration in it. So I am developing Aztec Next.js starter, and Aztec Next.js starter is basically, you can say it's completely like, full stack application sort of thing. Okay, so you have like, uh, everything that is there. Okay, so I'm going to paste data here as well. Okay, okay, okay. Okay, so let me, I guess, what we can do is, what we can do is, first I give the walkthrough through Aztec Next.js starter. Okay, and then we try to write a smart contract with a scratch, and then we basically, yeah, then we try to deploy that contract and do a whole bunch of stuff. Okay, so I guess that's the plan. So let's go to hashtag Next.js starter. Okay, let me increase the font size. I guess this should be good. Three. Okay, the naming here is a bit confusing. On my local, it is hashtag React starter. But anyway, this refers to the same project that I have linked here. Okay. So yeah, so me and my teammate, we are building this uh, hashtag React starter. Sorry, hashtag Next.js starter. Okay. So now let me walk you through the structure of this. Okay. So we have a, yeah. So we have at the very top level we have circuits folder. Then we have scripts folder, and then the src for Next.js. Okay. Let's go through the circuits. So the circuits are written in Noir, which is basically, the yeah, domain specific language to write, to create zero knowledge circuits. And yeah, it's also created by Aztec team. And similar to the package JSON, you have this Nargo toml. Nargo toml is Nargo. Let's talk about first of all, like, what is Nargo. Okay, Nargo, you can say, as a package package project management or package tool, some similar to, like, uh, npm or yarn, or in the Rust you have the cargo. So similarly to that, you know for the Noir you have Nargo. So like cargo, Nargo, right? It's the same thing. It's so basically you can say it's a project dependency management, project package management tool. So essentially, what you can do in Argo toml is, you can define all of your dependencies, name of your package, as well as the type. So your project type can be the type of code that you are writing. Can it be hashtag contract, as well as it can be a binary as well. Or if you are just creating some library with Noir, this can be the library lib. Yeah, and then you define the minimum compatible version, compiler version, and for our case, I have defined it greater than or equals to 0.180. Okay. So at the very top level for your Aztec circuits or Aztec contracts, you have this Nargo toml. Okay, and then you have this main.noir. So main.noir main.nr, basically we are creating here the contract, and the contract is essentially a voting contract. So what we are doing in this voting contract is, uh, anybody should be able to cast a vote privately. What does this mean is, if you are if you are casting a vote, the your address and the candidate detail, it will not be visible to anybody on the chain, yet it will still be there. So right, hence the concept of this privacy. You can see there are various macros, or you can say, yeah, so various macros basically, defined over it. So to create a contract, you define hashtag macro. Then for storage, there is a storage macro, and for the constructor, there is a initializer macro. You know, so these are all the various macros provided by the hashtag library that we can use. As you can see, we have already included hashtag library, hashtag package in the dependency. Okay, so this is the basic contract. We can compile this contract, cd circuits, hashtag hyphen nargo compile, and okay. So yeah, I mean, we just stepped into the stack, but we didn't talk about, like, how to get this setup on your local machine, right? So in order to install hashtag and everything, you need to go to hashtag network, and you have to download the sandbox and the tooling. So if you just go here, and you can basically, run this command to install all the tooling and everything. So I'll just mention this as well. Mm, mm, Install Aztec sandbox and various tools. Okay, so that's how you can install things. Okay, maybe I just take new box here, and we define, okay, first of all, let me log this instructions. Okay, and I can define, okay, install Aztec sandbox and various tools here. So once you run this command, you will have the, the hashtag nargo, hashtag up, hashtag wallet, and hashtag all the utility commands, right, to interact with the network, all will be installed. So if I do it, this will be all there for me, right? So let's say if I do this, okay, this will install the following part, but I don't want to do it. I don't want to change my version, and I'll tell you why. Sticking with a specific version is very necessary. Okay, I think this will not install any specific version, but before that, we need to start Docker. Docker is something that needs to be start up and running in order to have this setup. Okay, so I think we have our Docker running. Okay, I want to use the latest version actually, and the reason I'll tell you later why I don't want to use the latest version. Okay. Okay, so now okay, we have started our Docker, so we should be able to narco compile. We should be able to compile. So as you can see, there is no errors. There is no errors. So The comparison went successfully. There is one warning of unused function, node nullifier, but it is not inside our code, so I'm fine with it. Okay, so once you compile it, there will be a target folder with the, compiled JSON files. So these are, let me just remove this. Okay, so once we run it, again, you can see there is the target folder. And these files are called basically contract artifacts, right? So these are contract artifacts. This includes all the things for your contract, like ABIs, application binary interface, what are various methods and structures for your contract, as well as bytecode and all the things that is necessary for you to you deploy this contract. Okay, so now we have compiled it. We can also run the test cases with it. So you can just run Aztec test and it will run all the test cases. Okay, so you can see all the 7 test cases passed, and you might be wondering there are some errors, but those errors are expected because we are trying some failure cases scenario, like somebody trying to cast a vote again, you know, something like that. So you can see all of those test cases here, and there are, like failure test cases. That's why uh, when you run the stack test command, you will be seeing some errors. Okay, so this is for the test cases. Again, you can go through all of these test cases, but uh, what next? Yeah, by the way, you don't need to run these commands by coming into the circuits folder. There is a good scripts, like one run circuits compile. Okay, and similarly to that, one run circuits test. So yeah, you don't know even need to, like go to the circuits folder. You can run all the things from your top level as well. Okay, now once you have compiled the circuit successfully, and you have built this contract artifacts, the next thing you want to do is generate the TypeScript bindings for those artifacts. So, like so that you can use these contracts in front end. So what we are going to do is, this file is not important. I think I can remove this. I guess this is just okay. So also let me just you know commit this thing, because I don't need this. Remove unused code gen. Okay. So we can also discard this space change. Okay. So I guess so far this thing should be clear. Let me just recap. So at the very top level, we have circuits folder, scripts, and src. In the circuits are all of your Aztec contracts will live. The main file for the for your circuits or package file is package nargo.toml, where you define your all the dependencies for your contracts, as well as your this package name, and author and type, all the things. Okay, it's similar to the package JSON if you are coming from the on Node.js or Web Vault. So, okay, and then the entry point for your contract is src main.nr. Inside src, you can define main.nr, and where you can create the contract. The contract that we are creating is private voting contract, where anybody should be able to cast the vote, and then admin can end the vote, and you can basically all the other people, they can also get the vote tally as well. Okay. So that's the idea. Then there are test cases written in the noir, and there are various test cases. Okay, to compile the contracts, you can run hashtag narco compile, and also you can see all of these commands from your top level package JSON as well, where all the commands for build, compile, test, gate count, and code generation is. Okay, now after running the compile and test, we run one run circuits code check. So before doing that, I want to show you that in the SRC there is a artifacts folder. Okay, and this artifacts file is the one that gets generated when you run this code gen command. This easy private voting dot typescript file, it's the typescript version of your contract, right? Like all of it defines all of the contract interface, like what are all the methods that are available and all those things. So that is the command. So even if we delete this, let's say we delete it, okay, and then I run the file, run the command again, you can see that it gets generated again in the artifact easy private voting. Okay, so that's how we do it. Now let's try to deploy this contract without front end. We'll just deploy it with just a simple simple script. Okay, so I'm going to start the sandbox. Hashtag start hyphen sandbox. Okay, so as soon as you see that sandbox running on localhost 8080, that means your sandbox is up. Currently it's starting. Okay, so you can see this log that Aztec server listening on port 8080. That means your sandbox is up and running in good health. Okay, now we are going to go to this deploy contracts script. This script serves various purpose. One of the purpose is if you want to just learn how to write and deploy contract, but you don't want to care about the UI thing, like, or how to wire your contracts with the user interface, then it's good. And I I would personally recommend that I would personally recommend that anybody who is very new to Aztec, they first start with this script rather than jumping directly into the user interface. Sorry. So that's also the purpose of this script. Now, what we can do is okay, let me walk you through this script. So first of all, we are importing this method, get initial test account wallets, and then we are importing all of these dependencies, all of these methods from the Aztec. The very first thing that we want to do is connect to our sandbox. Okay, so this is the sandbox URL. This is our sandbox URL localhost 8080, and this method basically creates a sandbox client, create a Pixie client. I don't know if you are aware of the thing called Pixie, but if you are not and want to learn more, and you can just let me know in the comments, and I can create a separate stream on the Pixie. Okay, so we create a Pixie client, then we wait for the Pixie connection, and once the Pixie is created successfully, then we return the Pixie. Okay, this is okay. You can ignore this for now. Okay, contract address salt is also something that you can ignore. Okay, so what we are doing here is we are getting a wallet from the get initial test wallets. That wallet will be already available on the Pixie or on the sandbox. So we get the first wallet. Okay, we this is bit of a complicated method. This is like this is bit of too much, but what you can do. Okay, so this line, for your purpose we don't need it. we can just, I can just comment it. Okay, let me, I can just even remove it and put it here. I was trying something that if we have time, I can let you know later. But this is the flow. So you got the wallet, and yeah, you can print the owner wallet address. Let's say this is the wallet address. Okay, I want to use chalks, chalk dot green. No, yellow, yellow bright. Okay, now we are doing deploy. Okay, deploy transaction. Okay, there are two things. First of all, for the deploy, we are using this easy private voting contract, and from where we have imported it, from our code gen file, src artifacts easy private voting. Okay, easy private voting dot deploy, and the first argument, if you hover on top of it, you can already see like what are the parameters it is taking. The first parameter is the wallet, whoever is deploying this, and the second parameter is the constructor parameter admin, right? So if you look at it here, the constructor takes one parameter who is the admin of this contract, right? So whoever is the admin should be able to end the voting, and like, if there are other things, can do that. Okay. So we do, sorry. Okay, so uh, whoever is a admin should be able to end the votes and do all sort of things. So we are using the method deploy, and then we send it. This contract address salt, right? This contract address salt is and universal deploy. Ideally, like in the very basic cases, when you are just starting, you don't need to bother about them too much. You can, like, skip them. I'll just remove it. They are for a bit of advanced configuration, but we can talk about it later. Okay. So once you, okay, once you basically deploy it, in your deploy transaction, you will find the instance that is deployed. So deploy transaction dot instance dot address dot toString, right? So this will be the newly deployed contract address. Okay. And as you can see, we are already calling this script. So already in the main function calling this script. So let's run this script. We can run this script with the one run deploy contract. So this is the owner wallet address, and you can see contract deployed successfully. Okay. Mhm. Okay. So what I am going to do is, yeah, I will just do that, and I'll just comment this one and remove the sand from here, and one more comment. Oh, deploy contract with contract, predetermined style, pre with salt specific salt. So ultimately, what this salt thing is, if I tell you in a very brief, is like, this salt things gets into consideration when you calculate like what would be the your newly deployed contract's address, right? And with this salt thing, you can determine that address. Like you can have a say in that, like, like, okay, contract address gets calculated from various things, like, your constructor arguments, as well as whoever is deploying the contract, and the salt is, mm, like some seed thing, right? So yeah, that's the salt thing is. And if you want to predetermine your contract address, have more control over what the address should be, then you can pass the salt, right? And universal deploy is in the contract address calculation. You don't want the deployer address to play any role, but I think it's a bit too much right now, so we shouldn't even focus about that on that. So let's just okay. So we have deployed the contract. Now let's come to the front end part. Okay, so we are going to run the front end and run dev. Okay, I think there needs to be, I need to do one install. Okay, let's again run dev. Mm, okay, so right now there are two wallets in the ecosystem. One is the two wallets in the ecosystem, Obsidian wallet as well as the Asgard wallet. First, we are going to try the flow with Obsidian. But before starting on that, I want to tell you something, right? The thing with wallets is in Aztec ecosystem right now is that they are in very early stage. Okay, there are breaking changes every few weeks, so uh, like you need to be patient with them as well as like the transactions especially on testnet they takes quite some time. Okay, because Aztec ecosystem is in terms of the testnet and the proving things, it's just starting. Also, the other major factor for the transaction taking a lot of time is unlike other layer 2 blockchains, Aztec is fully decentralized from the get-go, right? Unlike other L2 chains which runs single sequencer and claims to be fully decentralized. That's not the case with Aztec. So even the testnet, it's completely decentralized. The second thing is there is a client side proving involved. So client side proving, especially on like limited hardware devices, like if your laptop has not really that much RAM and CPU power is also not that good, then the client side proving can take a bit of a time. So please keep these things into the consideration when you are trying things out. Okay, but when you are basically what do you say, trying with a sandbox, things will work pretty fast. So let's go to the Obsidian. So this is the Obsidian URL. Maybe I can just add these things in the resources. Resources. Obsidian wallet. Okay, this is the Obsidian wallet. Notes. Okay, so this is Obsidian wallet. Now you can see that my wallet is already connected with Sandbox. Even though that is the case, uh, if you are starting your Sandbox locally, the best thing you should do is reset the network, right? Because the account that you are seeing on this Obsidian wallet with Sandbox connection, that account is already gone if you have restarted your Sandbox. So I always reset the network, that is in the settings, reset network. Also, I open the console so that I can see everything is working correctly or not, because this Obsidian wallet is also in pretty early stage, so sometimes things just doesn't work, and you have to be patient. You have to ask a lot of questions in the Discord and in the to the Obsidian team, but they are very responsive and they help you like unblock the issues. Okay, so we have again connected, and since we are connecting from start, so for your purpose, I think I always go with the developer mode so that I don't need to create a new passkey and things, because I'm just trying things for the development purpose. So I'll just create it, especially on the sandbox. Like once you restart a sandbox, your account is gone, right? Okay, so my account is there. Account is 299A. What we will do here, let's just refresh this, connect with Obsidian. Okay, and your account is here 299. Okay. At the front end, we are using easy routing contract. So I'll show it to you how the code is, but let's try to first deploy this contract. Okay, so I'm trying to deploy the contract, sign in through. Okay, so contract deployed successfully, right? As you can see, contract is deployed successfully. We can check the votes. So current vote count for option one is 0. Okay, cast vote. We can cast the vote. Okay, vote casted successfully. Check votes, and the vote count is 1 right now. Okay, so we can do all of these things. We can try to do one more thing, though, like create a new account and app.obsidian. Let's switch it to, first of all, switch it to sandbox. It takes quite bit of a time to instantiate, so you can grab a coffee in the meantime. Okay, so new account got created. We can connect this account now, I guess, with the Obsidian. Okay, A61C. I always confirm my wallet because sometimes on your local storage there is a different wallet, and here you see the different wallet. So you can check the address here, your wallet address. So just click on this receive button, receive funds, and see address. Okay. Okay, so I believe the reason we are not seeing this is because what do you say? Because we are running a separate instance. That's why we are not seeing this. So that's not a good idea. So ultimately, like at least with the current code, I won't be able to, uh, do votes with a second account. Okay, that's not good, but that's fine. I guess we can add the logic later. Okay, let's try to do end voting. Okay, so voting has ended successfully. Okay, so you can see all of these functionalities code in source, source page.js have where all the code for the front end is like we are importing the AZ private voting contract and all those things. Also in the components header, we are making a wallet connection. Currently, there is a wallet connection for both the wallets, but contract deployment is only supported with Obsidian. I'm planning to add support for the Asgard wallet as well for contract deployment and all those methods very soon. Okay, so I guess that's pretty much it. These are methods are, I guess, very very primitive methods. This is the main file where you can see how we are calling various contract functions. For example, is this thing. Uh, this is different register contracts. This method is the contract deploy. Yeah, this is what we are doing. So deploy with options, and basically we are calling using deploy with options, and we are deploying the contract. And then these are methods for casting the votes and check votes. One thing that you need to keep in mind is, okay, I'm just mentioning these are features yarn dev. Okay, I'll just add a note here. You need to deploy, you need to register your contract first using the script run register contract before trying deployment using Obsidian wallet. Okay, so this is something that is very important, uh, and the reason for that is if your contract is not registered, the bytecode for your contract, or the contract class will not be available. And currently, with the current version with the Obsidian, somehow, I don't know, at least for me, the register contract method is not working. So I always have to register a contract with this thing. And that's why, there was this code of register contract. Let me just take this code and create a new script. Register contract.ts. Okay, so what we are doing, set up sandbox, register voting contract. We have the wallets, owner wallet address. We don't need to deploy anything. So I can just remove all those things. Okay, and register voting contract. Okay, and Aztec nodes. I can print the logs, but anyway, I don't need to do this, so I can also do this. Okay. So this way we would be able to register the contract. Let me just add this to the register contract. Okay, so we need to register the contract. Let's try this script if it is working or not. Then run register contract. Okay, the contract is already registered, so we are not able to register the contract. But if you see, you can see that existing nullifier, right? That means the contract is already registered. If you see that error, no problem with this. We can also, error dot, let me just see. Try catch error. I just want to see the if error dot to string dot includes dot to lowercase dot includes what did it include? Existing nullifier console dot log chalk dot, okay, what did it, chalk dot yellow contract already registered. So can we do a known? No. Any? Okay. Hmm. So you can see contract already registered is there, and we can see contract already registered. Okay, that's great. The way we can check if it is working or not, we can, start our sandbox all over again, and then we can check if it is working or not. Run register contract. I guess the sandbox haven't started yet. Okay, and you can see registration received. We need to do toString here so that we can see the hash. But now again, if we run it, we'll get the existing nullifier. Yeah. Okay, so let's see what are all the changes I need to do. GA script slash register and package.json script slash deploy contracts .js and readme bun.log. Also, I believe we can we can put this circuits target thing, circuits slash target thing in the gitignore file, circuits target or just target folder. Okay, so that way, even if I remove it, first of all, GA circuit slash target voting contract. Okay, they are already staged. We can also write this code.gen cache.json file. Okay, just the register contract script sanity changes. Okay, so I guess that's pretty much 8. uh, React, Aztec, Next.js, starter. So you can see, okay, you can see that our changes are here. We can now, we can now stop streaming. So this was like, my first attempt to basically explain what the, what this boilerplate code is, as many people are interested in, creating hashtag smart contracts. So that's pretty much it. And yeah, thank you guys.